Um, in this video tutorial, what we're looking at is we're still looking at triangle congruence, and we want to prove these ideas using a two-column proof. So let us see if we could get our two-column proof up and ready. So are we in the two column? And in one of the columns, we're going to have those statements. And the other one, we're going to have our reasons. All right, so for every statement, there has to be a reason. So let us start off with what's given, right? So start off with what's given all the time. So I'm going to list it. So item one, I was given that LM is congruent to NM. So LM, line segment LM is congruent to, or we could say the side LM right there is congruent to side NM. So in other words, then we were just told that this side is this side, right? And then X is the midpoint of ln. So we got that X is the midpoint of ln. All right, so we're given that. So let's put it on. This is given. X is the midpoint of ln. This is also something that was given. But with that given statement there, we are able to note that this is equal to this because the midpoint would have split the line segment from L to N. It's going to split that side into two equal pieces. So we can now state that LX is congruent to NX, and that is by the definition of midpoint. So by the definition of midpoint, we are able to tell that. Now, when we take a look at the situation, we notice that we need to prove that this triangle, L and X, we want to prove that this triangle is congruent to NX, and we want to prove that. So already we are seeing two pairs of congruent ideas. But when we take a look, both of them are sharing the same side, mx. So I could state that mx is congruent to mx, and this would be based on the reflexive property of equality. This is the reflexive property of equality would have told us that. So now it is that we have a third side. So as you could see, we have a side, side, side. So at this moment, when I realize that I have three sides, I could say that I could draw the conclusion that triangle LXM is actually congruent to triangle NXM, and this will be based on the side, side, side postulate. And based on what we have up here, we would have realized that we got number 1, 3, and 4. Those are the three sides. 1, 3, and 4 would have been the proof, solid evidence that we got from that. All right, so this would have helped us to prove this. And this is how we do a two-column proof, giving those ideas. Let's take a look at another problem. All right, so here we have the second problem, right? All right, so we want to prove that triangle ABD is congruent to triangle ACD. right? So that's what we want to prove. ABD is congruent to triangle ACD. All right, so let us drop our two columns. We'll be using our two-column proof. All right, so we're going to put our statements here and the reasons right here. All right, let's start off with what we were given. So that was actually given. All right, so because that was given, we are able to actually take things from this, and that this would have been a 90 degrees right there. So would have gotten a 90 degrees right here in both triangles, because that's what a perpendicular bisector does. So from that, I could pick out the fact that angle A, D, E will be congruent to angle A, D, C, right? So we would have picked up that from the two ideas, and this would have come by the definition of perpendicular lines. So based on what we know about perpendicular lines, we were able to tell that. All right. Also, we were given more things here. We were given that BD is congruent to CD. And this is something else that was given. Let us look at it. BD. All right, so this is BD, or it's congruent to CD. All right, so technically this is a perpendicular bisector then, right? So you could see that this is a perpendicular bisector. All right, good. All right, so let us take a look at what else do we have. So in this case, we actually have two things, right? So I'm seeing side and angle already, right? So if I can get one more proof, so let us see the fourth statement. When I take a look, I could say, hey, I'm noticing here that that DA is actually a side of both triangles. Then I could say that DA is actually congruent to DA, which means that that's the reflexive property, right? So using the reflexive property, I could now see that I have another argument. Then I have, when I take a look, I have a side, an angle, and a side. So then my fifth statement here could simply be that, hey, my fifth statement here could simply be that, listen, I have triangle ABD, which is now congruent to ACD. And this is the SAS because I have a side and the side postulate. And what are the, so if I take a look up here, first I got 2, which is the angle here, and I was given this side and we saw this side. So I'm looking at 2, 3, and 4. So this is 2, 3, and 4. All right, that's where, so this is an angle here, this is a side here, this is a side here. All right, so we have the side, the angle, the side. SAS, right? Let's take a look at another one. All right, so let us drop on 2 columns, statements. Let's write what we were given. So we were given that, number one, we were given that The angle 2 is congruent to angle 3, so that this angle is that angle, right? So this was a given. All right, so what else? We were also told that FE is congruent to DE. So FE, which is this side, is congruent to DE, which would have been this side, right? All right, so we have that. So FE is congruent to DE, and this was also something that was given. Now, I'm looking at the fact that I have angle in a side, all right? So there's a postulate that says angle, angle, side. If I can pull that out. So when I take a quick look at this, remember, if you see two lines that cross, then vertical angles are actually congruent, right? So whenever two lines cross, vertical angles are congruent. So I'm seeing that here. So this angle is vertical to that angle. So I'm going to draw on that this angle here is actually congruent to this. So 5 and 6 are congruent. So at this moment, I could say angle 5 is congruent to angle 6. And this would have been vertical angles. Mm-hmm. So vertical angles we're able to use right there. So now that I have, I'm looking at angle, angle, side. So the moment I could identify those, I'm ready to say that, listen, this triangle here, CED, it is congruent to the triangle GEF. And my reason would have been that AS, angle, angle, side postulate. All right? Angle, angle, side postulate right there. And let us see if we could identify what we have. We have number 1, number 2, oh, 1, 2, 3. So this was actually a nice 1, 2, 3 here. We have 1, 2, and 3. Those were the proof that we got to concretize the idea. Thank you for watching Dynamic's Concepts, and see you next time as we look at more ideas.